I feel like a section that we need some work on is the one that we just finished, which was applications of derivatives. I feel like we need to focus there because you guys felt weak on it from what I was getting from you, like you didn't feel like you did well with that workbook last week, but also because this is like a seriously heavily tested concept on the test. So I think it'd be really good to focus on. So let's go ahead and begin. So and like I said, this would be basic review. And all this is for just laying the foundation of the concepts that need to be in place so that you can do the more challenging questions, okay? By the way, basic doesn't necessarily mean less work. It just means that it's the basic concept. So let's go ahead and do these. So for each problem, find all points of absolute minima and maxima. As you guys know, that means candidate test, right? Candidate test means critical values and endpoints. You have to pay close attention to where they are asking, whether they're asking you for the x values, or if they're asking you for the y values, or if they're asking for both, like as a point. So it says find the point. So for our answer, my answer is going to be x comma y, right? But sometimes they'll say find the x coordinates, or they'll just say find the maxes. The maxes are the y values. So you got to read the directions to see what they're actually asking for. Okay, so I would underline that too, points. All right, so here we go. The endpoints are obviously -4 and 1. Let's go ahead and find the critical values. Critical values are where the derivative equals 0. And that would be at x equals what? -3. Okay, so we're going to start with our endpoints, -4 and -1. And -3, is that in my interval?
Yes.
Yes, it is. So we're going to include it. If you ever get a critical value that's not actually in the interval, then you don't use it. And at this point, we just need to figure out what is y of -4, what is y of -3, and what is... Yep, plugging it into the original equation. So let's go ahead and do that. For this one, I'm going to go ahead and do it mentally if you guys don't mind, but if you want to see it, let me know.
I want to see it.
Seriously?
No, I'm just kidding.
Okay. 16 minus 24. What's 16 minus 24? -8?
Yeah.
Plus 3 is -5. 9 minus 18 is -9. Plus 3 is -6. And then 1 minus 6 is going to be -5 plus 3. Okay, so which of these is my max?
-6. So y equals -2.
Oh yeah.
And what's my min?
-6.
Okay, so but remember, they wanted the point, right?
Yeah.
So remember, if they ask what's the min, what's the max, they're talking about the y values. If they ask for what's the x coordinate which they occur, then it's these ones. But in this case, they're asking for the actual point. So we would say absolute min is at the point -3, -6, and absolute max is at the point -1, -2. Final answers. So there's the process. So I'll number my steps for you guys. What I did was this was step 1, this was step 2, 3, 4, 5. Yeah. That's right. So let's label that. That's a critical value. That's correct. That's correct. All right, so that's how you find absolute extrema. Okay, absolute extrema means it's the the highest and lowest point on the whole interval. Now there's this other thing called relative extrema, which means they're the highest point within that immediate vicinity, but not necessarily the highest point overall. Okay? Kind of like we have a person in this class who's probably the tallest in the class, but maybe not the tallest out of the entire school.
Noah?
Maybe.
No, duh.
You think Noah's taller than Will?
Yeah.
Yeah?
No, Will just has long legs and can jump
We'll
I feel like Will's taller.
have to see sometime. I'm curious. But right now I'm going to proceed. All right. So let's go ahead and talk about number 2 here. So now this is a different question.
First derivative.
Yep. This one's asking us to find relative extrema. Now there's 2 ways to identify relative extrema, and they're pretty much the same. You guys probably don't even remember the second one, because honestly I never use it. It comes in handy once in a blue moon, but it's kind of like, okay, it's nice to know. It's called the first derivative test, and the other one's the second derivative test.
Interesting.
We'll see what the second derivative test looks like in a minute. But for this, we're going to use the first derivative test. This is the one where you find where the derivative equals 0, and then you find where it's positive and negative. And you can tell from where the derivative is positive and negative.
Yeah.
The number line test, right? So you can call the first derivative test like the number line test. All right, so here we go. So step 1 is to find your critical values, and you do that by finding the derivative. And the derivative, you're going to look for where the derivative equals 0, but also where it's undefined. Now, I didn't do that in the last one. Does anybody know why I didn't do that in the last one? It's never undefined. That was a polynomial, but this is undefined somewhere. All right, so here we go. Let's do low, D high, minus high, D low. Draw a line, square below. All right, and let's simplify that. So this whole thing is gone now, right? It's all times 0. So I'm left with negative 6x over x squared minus 9 squared. All right, so do you guys remember where a rational function is equal to 0 at? How can you make a rational function, find where a rational function is equal to 0? The top, right? So we're going to take the top and set that equal to 0, and we find out that it's equal to 0 when x equals 0. How do you find out where it's undefined? You set the bottom equal to 0. Now if I square root both sides, right, that's just going to give me this. Oops. Then I'm going to add 9 on both sides, right? And then I'm going to square root. Now this is something that you guys forget about a lot, though, I've noticed. It's plus and minus 3. When you take a square root, you do plus and minus. I didn't do that here because it was 0. There's no such thing as plus and minus 0. But any other number you do need. So I've got actually 3 critical values that I need to test. So step 1 is to find your critical values. You want to find where the derivative equals 0 and where it's undefined. All right. The next thing you're going to do is you're going to do your number line test. Okay. So we have a negative 3 critical value, a 0 critical value, and a 3 critical value, which gives us 4 intervals of interest. Yep, we need to pick one number from each. So let's go ahead and figure out what y prime of, sure. Yes, for this one you plug it into the derivative. I'm going to plug in these numbers here and see what we get. So, once again, I'm just going to do this mentally. So on the bottom, you guys notice it's always going to be what? Always positive. Why? It's being squared. So it doesn't matter what I get them. I'm going to ignore the bottom. It's always positive. Okay? So let's just look at the top. If I plug in a negative up here, what's it going to be? If I plug in a negative, again, still positive. Plug in positive, and
negative.
okay. So what does this mean about? So what does this plus mean? First of all,
It's going up. Going up.
it's increasing. How about here?
Going up.
And here?
Going down. Going down.
And here. Okay. So that means that y of -3 is what?
Undefined.
It is undefined, but it's neither a max or a min.
Oh, zero is a max.
Maybe. Probably, actually. 0 is, it could be a max. I'm going to put a question mark, and I'll tell you why in a minute. But let's come over here to this one.
The same as -3.
Yes. I'm just going to put neither this time. Because it has to change slope at that point in order for it to be a max or min. Why is there a question mark, though, on 0? It's only a max if the point actually exists. So we have to actually go ahead and plug it in. Now, what is our problem asking for anyway? It just wants to know what the extrema are. So does it want an x value, a y value, or a point?
Point.
No.
Oh, relative extrema, wouldn't that be the y?
It's just the y value. So let's go ahead and plug in and see if it works. Okay, 3. So there it is. This is the relative max is y equals -1/3.
So you plug it in the mean equation, and that's 0?
Yeah. Because remember, when you're talking about what an extrema is, that's an actual y value. So for the number line test, you plug it into the derivative to find out what's going on with your slopes. Then you plug it into your original to find out the y value. But remember, pay attention to your question. Is it asking for the x value, the y value, or a point? It really stinks to actually do all the math right and then get it wrong. I've seen that on an AP prep test where like they actually have the x value as an answer, but they wanted the y value because they said find the max. So they'll do stuff like that. You got to watch out what they're asking for. Oh yes, thank you, David. I forgot to do my intervals, so let's do that. So next part of the question, let's talk about the intervals because it did ask for that.
So -3 is increasing. 0 is a cusp, and then 3 is decreasing.
0 may not be a cusp, but it looks like a cusp from how I drew it. So we would say that from what to what?
0 to 3. Oh, negative infinity to -3.
Good. Is unified with -3 to
0.
0 is all increasing, and interval of decrease would be the other two. So that would be from 0 to 3 unified with 3 to infinity. Okay. So that's relative extrema. So now we see that there's absolute, there's relative. Absolute is candidates. Relative is first derivative test. Good? I think people are still writing. I'll wait a few more seconds. For each problem, find the x-coordinates of all points of inflection and find the open intervals where the function is concave up and down. All right, so points of inflection happen where the concavity changes. How do you find concavity?
Isn't it when they pass the x-axis?
It depends. But what I was looking for is what I heard someone say back there in the back of the classroom, which was that you look for the double prime. So first, that's the first derivative. First derivative can tell me where it's increasing, decreasing, and help me find relative extrema.
Points of inflection is y.
But second derivative helps me find concavity. If you know concavity, you can find your points of inflection. So second derivative is going to be 6x plus 10. You're going to set that equal to 0. And you're going to solve for x. So minus the 10 and divide by 6, you're going to get 5/3. So that's a potential, notice I said a potential point of inflection. It's only a point of inflection if what happens there? That's right. Is it negative? Thank you. A potential point of inflection. So let's test it to see if it is. Negative 5/3. Now, negative 5/3 is 1 2/3, so about negative 1 2/3. So I might pick like -2 over here, right? And then over here I might pick 0. I think 0 is a really good one to go with. It's nice and simple. So if I plug in 0, what do I get? Now, what am I going to plug it into?
Second derivative.
The second derivative. So if I plug 0 into my second derivative, I get
Positive.
a positive. And if I plug it in a negative,
Negative.
so is that a point of inflection?
Yeah.
Yes.
Yes, because the concavity goes from concave down to concave up. So concave down on the interval -infinity to -5/3. Concave up on the interval -5/3 to infinity, and therefore x equals -5/3 is a point of inflection. So once again, I'll number my steps. The first thing I did was I found the second derivative and set it equal to 0. Second thing I did was the number line test again, find out where the concavity is actually changing. This is a really good one to talk about. If you were here Saturday school, this will be kind of chill for you because we spent some time on these in Saturday school. If not, this will be a great review for you because our last mock AP test had 2 of these on there. They're pretty common. You can probably expect to see at least one of them on your AP test. They're called related rate questions. What it is a problem where you're given one rate and you're asked to find another rate. So I'm going to give you the steps exactly as I gave them to you last time. It's a nice little thing to throw in a flashcard and memorize. If you follow the steps, you'll pretty much have a pretty easy time with it. So the first thing you want to do is you want to identify the given rate. So let's read it. A hypothetical square grows so that one of the lengths of its diagonals are increasing at a rate of 5 meters per minute. How fast is the area of the square increasing when the diagonals are 8 meters each? All right, so first thing we're going to do is we're going to write down the given rate. The given rate is the diagonal, right? So the rate of change of the diagonal, we're going to call that ddt. The rate of change of the diagonal with respect to time is 5 meters per minute. You also have to keep an account. You might want to make a little note here. Watch for negative rates. At this point, if they tell you that it's decreasing, then you're going to make that number a negative. They're not going to make it a negative in the word problem. They're going to say it's decreasing. So if it says it's decreasing, it's your responsibility to make it a negative here. Okay? In this case, it's increasing, so I'm going to leave it as a positive. All right, step 2. Let's identify what we're trying to find. I'm trying to find what? The rate of the change of the area. So this D represents diagonal, this one represents area, right? So we want to find that. Now, it's also good to think about what your units are going to be. So what are the units for area? Meters squared. And since it's a rate, it's meters squared per minute. Okay? Okay, so we need to find that number. That's our goal. I should have titled that. I'll put the title underneath. Identify the rate you want. So we identify the rate we have. We identify the rate we want. Step 3 is sometimes like on both of the ones from our test on Friday, they actually made it easy for you. They gave you the formula. This one we have to figure it out. So step 3 is to find a formula that relates the two variables. And this is the hard step. The reason why this is a hard step is because it requires you to know some pre-calculus math to do it. So we have a square and it's got a diagonal. We'll call that D, right? What should I call the sides? S. Now, first of all, what's a formula for the area? You guys good with that? But let me ask you, does this equation connect the area and the diagonal, the two variables I care about?
No.
No, it connects the area and the sides. So this is a hard one. Usually, the easy ones, super easy, is just when they give you the formula you're going to use. That's what was on your test. Somewhat easier is whenever you just have to do one equation to get your thing. This one's a little bit harder. You're going to have to find another equation and make it fit the way you want to. So I'm kind of giving you a worst case scenario. What else do you guys see we could do up here though? How can I create an equation with a D in it? Can you guys figure one out? Pythagorean theorem, right? S squared plus S squared equals D squared, right? So let's write that. S squared plus S squared equals D squared. Now here's what I'm going to do. I want to get this S out of there, right? So, and I want to replace it with something with a D instead, correct?
Yeah.
So what I'm going to do is I want to find out what is S equal so I can plug something in for it. So let's solve for S over here. So first of all, I have this, right? You guys good? Mm-hmm. And I want to get S by itself, so what would I do? Now what would I do? It's supposed to be a 2. There you go. So now S equals this, right? So I can just come over here and replace the S with and now I have, do I have an equation with the two variables I care about?
Yeah. Yes.
Now I do. So just so you know, some of you guys might be thinking, oh, I'm screwed on that one. This is a very hard one, but this is worst case scenario. Yeah. Over square root of 2? You could do that, but I didn't because once you plug it in here, the 2 is just going to cancel out the root. You're going to have this anyway, so it's all good. All right, so step 1, identify your given rate. Step 2, identify the rate you want. Step 3, find a formula that connects the two variables that you care about. In this case, D and A. We got there. On your test last time, like I said, you didn't have to do any of that. They just gave you the formula up front. So that was nice. I still think a lot of people probably missed it because these are multi-step problems, so you probably forgot all the steps, which is fine. But I think once you know these steps, you'd be like, oh, okay, it wasn't too bad. All right, so the next thing you do after you find your equation is you're going to find the derivative of that equation. So A equals D squared over 2. All right, so it's going to be A prime equals what? You could do that, but if you just do the power rule, 2 to the front, they cancel, right? And it's just going to be D. But we're finding the derivative with respect to time, so what do I need? Yeah. And maybe I shouldn't write this. And instead of writing A prime, I'm going to write D ADT. So this is a lot like when you do implicit differentiation. You just take the derivative like normal, but every time you do it, you put a prime next to it also. Okay? All right, so now we're going to start, after that, step 5 is to plug and chug. So plug and solve. So here we go. Do I know D80T yet? No, that's what I want, so I'm going to leave that alone. Do I know my diagonal?
Yeah.
What is it?
Just kidding.
It's a, do I know my rate at which the diagonal is changing?
5 minutes.
And so the answer is 40 square meters per minute. So we spent 2 days on this last time, and you guys got pretty comfortable with it, but you just need to refresh yourself with those steps. Step 3 will never be easy. It's always challenging, unless they just give you the equation, right, which could happen. But steps are the same for all of them. Identify the rate you want, the rate you need, the rate you have, write an equation, take the derivative, plug and solve. Okay, it always works like that. All right, I think we'll probably just stop there. And we will see you guys mañana.